Hello, everyone, and thank you for joining our webinar today. Today's session is called, What is Deep Energy Retrofit? A nuts and bolts explanation of high-performance retrofits, plus rebates and resources to get you started. Before we start, I would like to take a moment to recognize the traditional Indigenous lands where Eco-Canada's office is based in Calgary. At Eco-Canada, we're committed to working towards respectful acknowledgement, collaboration, and reconciliation with Indigenous peoples across Canada. This starts with acknowledging our honor and privilege to live and work within the Treaty 7 territory. Today, we are presenting from the city of Calgary, home to the Métis Nation of Alberta, Region 3. We would also like to take this time to acknowledge the traditional territories and oral practices of the Niitsitapi, home of the Blackfoot Confederacy, which includes the Siksika, the Piikani, and the Kainai First Nations, and the Tsuut'ina and Nakota, Stoney Nakoda, which includes the Chiniki, Bearspaw, and Wesley First Nations. My name is Danielle Fisher, and I'm the lead event manager for Eco-Canada, and I will be moderating this webinar today. Before we start, there are a few housekeeping guidelines for today's session to ensure that everyone can enjoy and participate in the webinar effectively. All participants are muted, so please check your audio settings to ensure that you can hear us properly. If you are experiencing any technical issues, please use the question box and select Eco-Canada, the organizer, and I will do all that I can to resolve the issue. Today's webinar is being recorded and will be made available to you within the next 24 hours. Everyone who registered for the webinar will receive an email and a link to the video. Any questions that you have about the presentation or today's topic can be submitted through the chat box or question box. We will have dedicated time after the presentation to answer any questions from the audience. Finally, we really want to know what you think about our webinars and how we can keep improving. You'll be sent a short survey after the webinar ends. Please let us know what you think or if you have comments or suggestions about the webinar. Eco-Canada is the steward for the Canadian environmental workforce across all industries. We champion the end-to-end career of an environmental professional. We not only train and certify professionals, but also help identify and address labor market gaps. Our efforts promote and drive responsible, sustainable, and economic growth to ensure that the environmental care and best practice is a priority. For those looking to enter the environmental workforce, Eco-Canada provides training through the BEAR program and accreditation for environmental programs at post-secondary institutions. Eco-Canada also provides opportunities for new workers to break into the environmental sector through wage funding for co-op students and recent post-secondary graduates. For those already employed as environmental workers, Eco-Canada provides the environmental professionals and environmental professionals in training certifications. Lastly, Eco-Canada provides opportunities for those with vast experience as environmental workers to provide guidance and direction to Eco-Canada's products and programs through advisory committees and emeritus membership. Without further ado, I will now introduce our wonderful presenters today. First up is Jillian MacArthur, the Communications Specialist at NIEMA Canada. Over to you, Jillian.
Okay, thanks, Danielle. And thank you all for joining us for today's webinar. Like Danielle said, my name is Jillian MacArthur, and I'm the Communications Specialist here at NIEMA Canada, which stands for the North American Manufacturers Association. NIEMA Canada represents the fiber insulation manufacturers of Canada and North America, and our team efforts focus primarily on promoting energy efficiency through building envelope improvements for both new and existing buildings. In today's session, we'll explore deep energy retrofits. Canada has millions of buildings that are due for an efficiency overhaul, and the deep energy retrofits are the solution. What is a deep energy retrofit and why are they so important? Let's break down the concept and demonstrate the critical need for this construction strategy. During this session, we'll be covering what a deep energy retrofit is, the process, and financing, including resources and rebates to share with your clients and yourself, so stay tuned until the end. Our presenters today are Andy Coburn, Director of Education and Training at NIEMA Canada. Andy is a Red Seal general carpenter with experience in restoration, traditional timber framing, drafting and design, stairs, custom housing, and high-performance residential. Throughout the early 2000s, Andy taught at the Algonquin College Perth campus in construction carpentry advanced housing. In 2017, he earned his certification as a passive house consultant. With us today, we also have Gary Sharp, NAMA Canada's Senior Technical Advisor. Joining us for Q&A. Gary is a licensed professional engineer and has been involved in the construction and renovation industry for over 25 years, always working towards improving the energy efficiency of Canadian housing. He managed the National CHBA Builders Manual for the last 5 editions, spanning 25 years. Excuse me. While at the CHBA, Gary was staff lead on their Technical Research Committee and the Canadian Renovator Council and Home Modification Council. He also served as representative on the National Building Code Advisory Board. If you want to get in touch with any of us, our contact info will be at the end of the presentation. And now, without further ado, it looks like the presentation needs to pop up, but once we get that going, we can turn this over to Andy. If you just bear with us for just a minute and we'll get that going. If you have any questions during the presentation as well, please feel free to put them in the Q&A box and we'll get to them all at the end of the presentation.
Can you see the presentation there, Jillian? We
can. Thank you.
Okay. And thanks very much, Jillian. And thanks to everybody for joining us. It's nice to be here with Eco Canada again. And today I want to go through a bit about deep energy retrofits. And much like this deep dish pizza, a deep energy retrofit can be quite satisfying. Forgive the comparison, but to be honest, I was racking my brain trying to come up with a better pizza joke, but everything else was just too cheesy. So moving right along, as we go through the next half hour, I would like to explore the concept and definition of deep energy retrofit and talk about why they're important right now. I'll talk a little bit about how deep energy retrofit processes work and wrap up with a look at how we might pay for that work. The first thing we need to do to understand what this process is understand what is a deep energy retrofit, what it means to get one. The folks at Natural Resources Canada describe energy retrofits in broad terms. Upgrading energy consuming systems, especially equipment for heating, cooling, and hot water, improved electrical and lighting, more insulation, better windows and doors, and improved mechanical ventilation. It's also worth mentioning that, as Enercan does, that the process and execution of an energy retrofit should incorporate energy efficiency measures. And what that means is you might have recycling of demolition materials or supplies that are brought to site from within a 100-kilometer radius, or perhaps even using renewable energy power to run your tools or vehicles on the site. With a deep energy retrofit, Natural Resources Canada describes the goals of the improvements to lower energy costs, reduce maintenance requirements, create a better indoor environment for occupants, improve the value of the building, and ultimately reduce the environmental footprint. Natural Resources Canada and the National Research Council of Canada, or Enercan and NRC, are the people who produce our National Building Code and National Energy Code. In the coming decade, we may see more stringent expectations for energy efficiency and GHG calculations, and I'll get to talking about that in a few minutes. There are 3 main points I want you to keep in mind. Deep energy retrofits are necessary to 1, reduce our energy consumption, and 2, reduce the environmental footprint of our buildings, and 3, reduce operational greenhouse gas emissions as much as possible and as quickly as possible. If we focus our efforts on these 3 themes, our energy retrofits could have a significant impact on Canada's climate change mitigation strategy. We can further define the concept of a deep energy retrofit by looking at it through the lens of conservation of energy. To reduce energy demand, greenhouse gas emissions, and environmental footprint we make with our buildings, we need to do a good amount of work up front. The planning and design of assemblies and systems for the retrofit has to be careful and thorough. The preliminary planning has to laser focus on creating building envelope assemblies that work to conserve energy first, if we can reduce the energy impact with static elements, meaning elements that aren't machines, for example, like insulation, windows, doors, and air tightness strategies, we'll be in a better position then to get the most efficiency from those machines, mechanicals, and electrical systems. You might be saying to yourself, now, hold on, Andy, why are deep energy retrofits so important, and why now? What's with wanting to get a deep energy retrofit? Why is that so important? That's a fair question. And I don't think it's very hard to find the answers to that. You only have to pay attention to the weather and to what's happening in Canada and around the world. 10 of the hottest years on record have happened since 2010. We're seeing more extreme heat days, more drought, more flooding, and more wildfires. Just this last year, as this thermal image from NASA shows, the west coast of Canada and the United States were impacted by an incredible heat wave. The subsequent dry weather and wildfires in British Columbia burned the town of Lytton right off the map. Now, in their report titled Climate Change 2022 Impacts, Adaptation, and Vulnerability, the International Panel on Climate Change provided a heat projection for the middle of the century that shows the heat-related effects that may happen. The dark red locations on the map are areas that are likely to experience extreme heat and may pose a threat to humans, animals, and plant life. Many of these areas just so happen to be the most highly populated on Earth, or in the case of the Amazon rainforest, are regions that act as the lungs of our planet. Now, you'll probably notice that RCP gradient across the top. That refers to the concentration of carbon that delivers heat energy in watts per square meter, and it's used as a best case, worst case measure for the impact that increasing heat events may have. From left to right, you can see that the hotter it gets, the more regions will feel negative effects and potentially life-threatening effects all year long. Most recently, the east coast of Canada was subjected to hurricane weather in the form of Hurricane Fiona. This kind of weather event happens relatively infrequently in the maritime provinces, but something so destructive and in such a wide swath of provinces was unique. So people in Nova Scotia, PEI, and Newfoundland, Labrador, some are still cleaning up after that. And some coastal towns, like in the photo on the left-hand side there, is the town of Rose Blanche, Newfoundland, where buildings were picked up off their foundations and dumped into the ocean. This is turning into the new normal. Changes to our environment and the common expectations we have for weather patterns, meaning what do we normally expect? What can we expect that the people on the Weather Channel are going to tell us? With these kind of changes that are happening and with this unpredictability, it's going to play havoc with our energy systems and infrastructure. We're forced to pay attention when events like hurricanes and tornadoes or extreme heat cause our systems to drop out. The IPCC highlights the imperative in this graphic from that study I mentioned earlier, showing the fragility of our social structures and reliance on energy input. The need for deep energy retrofits is heightened by climate change events, stressing the importance of a built environment that is less dependent on energy grids or that may have more resilience in extreme weather. Knowing where we are in terms of environment prompts the next question. What's it going to take, and what's going to happen with a deep energy retrofit that will make our buildings more efficient and more resilient? How will they make an impact to the environment? Now, as a builder, I find this inspiring, and there's a little bit of hope there. I know that the assemblies and systems that we need to integrate into our retrofits are commonly known. We know how to do the construction and renovation with these materials. We can do this. It's not going to be a small job, and quite the opposite, in fact. But we can do this if we inspire many hands to help us make this work go forward. But case in point, our first steps will involve the implementation of building science fundamentals, managing the flow of air, heat, and moisture in and around our building. We understand the physics of buildings quite well because we've been chipping away at this rock since the late 1980s. Canada, as it happens, was instrumental in developing programs, especially one like R2000, which is one of the first and longest running energy efficiency programs in the world. Understanding the basics of building science is not a great leap for us. It's not a steep learning curve. The initial stages of our deep energy retrofit are going to be heavy on the planning and inspecting. We need to perform energy audits, thorough inspections, and even interviews with building owners and occupants to understand how the building performs. We'll test the building with blower door systems and check all of the assemblies, equipment, and openings. Ask the homeowners or building owners, where are the cold spots? Where are the stinky spots? Where do you smell mold? Or is it dry? Or is it overly humid? With this information, then, we can establish a baseline. This is kind of like a how is the system working right now measurement of energy consumption and envelope effectiveness. We can use that then to plan the improvements. The better we understand how an existing building is performing before the retrofit, the more effective we can be in creating a highly energy efficient solution in envelope improvements. Now, that planning and design process, it will look primarily at something called the control layers of the building, which are insulation, air barriers, vapor and water management layers. That includes windows and doors, and that even includes penetrations for things like plumbing and heating, attic hatches, and that sort of thing. When you combine these envelope elements, you can more effectively control the flow of heat, air, and moisture like we talked about. For example, if we create a strong thermal boundary and a very airtight assembly for our walls, floors, and roof, then we will have an easier time creating a truly climate-controlled environment inside our buildings. I know you've heard that term before, and this is really what it means, that we can design the most effective envelope, tighten up our building to the point where then we can bring in the most effective mechanical systems for heating, cooling, hot water, and most importantly, for mechanical ventilation. Planning for the use and installation of control layers is critical to making high-performing deep energy retrofits work. To give you an example of what I'm talking about, here's a treatment for an old rubble stone foundation from Joe Stiebrick at Building Science Corporation. As you look at here, you're seeing what is probably a cellar space that's common in towns and cities all across the country, if not all across the world. With careful detailing and proper sequencing and layering, you can take something quite challenging like this and make a significant improvement in energy use and comfort. The same thing here. This is a building a little more modern. It's from the 1970s. To improve the performance in that same location in the basement, we might look at mapping out for moisture management layers and insulation, coupled with perhaps a sleeper floor and wood framed walls to the inside. This approach doesn't involve, and I want to point this out, that this doesn't involve any new technology or futuristic materials. Most of these materials are commonly available now in supply stores. It's the planning and design that's critical here. We need to get this right when we're preparing for this deep energy retrofit, because when you think about it, we're not going to have another stab at this. If we enter into the retrofit and we actually spend time and money doing it, we're not going to get another chance at it for potentially another 50 or 60 years. Now, thankfully, we're not going to have to guess at a lot of these assemblies and procedures to achieve a deep energy retrofit. Once our baseline is established, once we know how the building is performing, we can then choose from comprehensive energy efficiency programs such as Net Zero, Passive House, and LEED, all of which contain prescriptive information for achieving energy reductions and lower emissions. And all of these programs offer help for designers and builders so that the execution of the project can be properly done from start to finish. In Canada, we're aiming our future building codes to achieve net zero, and this is where we're going to eventually get to the point where all of our buildings, their performance will equal or exceed net zero guidelines. Targets for energy use and reduced emissions are closely associated with these labeling programs. And what you're seeing on the screen is a label that would be on a net zero home. I talked earlier about what kind of focus we would have when we get into using some of these programs. And this is what specifically I'm talking about. Our value and air tightness are maximized in our retrofit. We're looking to super insulate, and we're looking to get the air change rates, or our ACH, down below 1. We might do this by setting a tangible target for annual energy use and then work backward from there, kind of reverse engineering. For example, we might follow the net zero energy target for annual energy demand at 40 gigajoules, and we can ask our energy advisor then to help us model assemblies and systems to achieve that goal through construction. In all energy retrofits, we need to include constant mechanical ventilation with heat recovery. Creating a tight envelope begets the need for fresh air and exhaust to keep the indoor air quality high. An HRV or ERV unit, an HRV is heat recovery ventilator and ERV is enthalpy recovery ventilator. These are the units that we use to keep fresh air flowing constantly in a controlled manner. And with more governments around Canada and the world courting the idea of phasing out fossil fuels, we'll need to plan for electrical systems for our heating and cooling. And the electrification of systems is a big topic. You've probably already heard either commercials or you've heard it in conversation about people considering bringing in an HVAC company to install an air source or ground source heat pump. This is where many HVAC and mechanical experts are headed into the future. Without a proper and purposeful building envelope strategy, mechanicals can't take care of the problem entirely. They can help greatly, but they can't do it entirely. We need to make sure that we are doing the whole job and making sure that we're doing the complete process. Finally, we need to make sure that we are checking our work during the retrofit process and after occupants move in. So that means that auditing or testing process is going to happen at several stages. The reason why I want to do this is because we need to confirm that those great things that we planned actually are working and doing the job that we modeled them to do. The physical job of the retrofit process is meant to create a better performing, more comfortable, more easily managed living space. The improvements might also include measures to allow for occupants to age gracefully, the aging in place idea. One contentious aspect of performing deep energy retrofits is where the occupants of homes and apartments will live while the work is being done. This is a real head scratcher. In a majority of cases, it's not going to be possible for people to live in their homes or in their units while the retrofit is taking place. Couple that with the fact that we're also in a bit of a housing crisis in this country, and it makes it even more of a problem, even more challenging to solve. We will need a system that works to temporarily house people while these renovations and retrofits are going on. It's got to be all hands on table and all brains in effect here. We need to make this work go smoothly. The changes that take place in a deep energy retrofit may not change the look of a building very much, but it may add many more years of useful life to the building. Both of the buildings that are shown now, they're both from the era of post-World War II victory houses. They're both given a new lease on life with retrofits. Our thinking around longevity of our buildings, and especially with these kind of examples, we need to shift our focus from thinking our building life is going to be 50, 60 years, and we need to start thinking a lot more longer term, 100, 150, 200 years. This is going to help us to be resource efficient as well. If we use materials that can last a long time, we're going to lessen our impact on the environment. With all this, you'd be correct in thinking the process is not going to be easy and it's not going to be cheap. We have a lot of work ahead of us. We'll need many options to finance the effort. As for costing, it's not out of the realm of possibility to see individual residential buildings with retrofit price tags over $100,000 per building. Even more so with multi-units, MERBs, and high-rises apartments. You could be in the many tens or hundreds of millions of dollars to retrofit those those situations. But it's not impossible. It's being done now. Things are happening in this regard, and people are actually doing this kind of work. Federal governments and the provincial governments and state governments in Canada and the United States are creating home energy loan programs. In Canada, we have the Greener Home Initiative for loans and grants, rebates on energy retrofits. Even municipalities are getting into the act, with some providing ample funding to improve the energy performance of buildings. And I'm speaking specifically about Greater Toronto area has a really good system in place where they've got up to $125,000 of stackable loans. We have approximately 15 million existing buildings across Canada that need energy retrofits, with just about 1 million of those being apartment units. Canada is 10 times smaller in terms of population than the United States. But both countries, and if not most developed countries in the world, will have a massive amount of work. But with that work, we could make significant changes. It's going to be a significant cost to governments and homeowners alike, but we could make significant changes. Now, the challenge of financing energy retrofits across North America requires us to take a new perspective on how we're spending the money. We know that we need to lower our energy demand and emissions as quickly as possible. That's job number one. So our primary focus must be with these concepts in mind: energy demand and emissions right away, as soon as possible, get them down. With that in mind, we can't create a boutique program. We can't create something that only delivers to a small affluent section of the population. We need to apply universal and effective program that tackles operational energy reduction and GHG emissions, implementing envelope improvements and mechanicals in concert with one another. A large portion of our population, this is a given. They're going to need help with the cost. However, we've got things in place like something called PACE financing, which stands for Property Assessed Clean Energy Financing. And this creates a model where energy retrofits can be amortized over several years through municipal property taxes. So it stays with the building instead of staying with the owner. And PACE programs are already working in some parts of the United States and in Nova Scotia. We face great challenges with how we prepare our social structures and build up capacity for executing deep energy retrofits. We need thousands more builders, more building inspectors, more energy advisors, and more designers. We also need to carefully consider the embodied carbon that exists in our material extraction, manufacturing, and distribution. The more carbon we can take out of the process now and lessen it from the birth, or rather the extraction of the product and all the way to its disposal, the better off we're going to be. Less carbon in the air is better. The challenges identified earlier with housing and disruption are also going to need immense help from the social services sector. This is exciting to me just because this adds in a very human element to this work. We're up against a veritable mountain of issues that don't have simple solutions. And so we need to draw from different sectors to help us provide those solutions. Many hands are needed to make sure that we can get through this. But just before I finish, a few words of inspiration. We have to remain optimistic. We have to focus on solutions. We know how to do this work, and we're capable of doing great things when we focus our energies. Our world is full of opportunities for learning and creating, and we need so many more people of like mind to jump in. Imagine this: if we could retrofit all of the existing buildings in Canada over the next couple of decades, we could potentially make a giant dent in the energy demand and GHG emissions just from building improvements. And we could quite literally be saving the planet and humanity with deep energy retrofits. Thank you very much for listening today, and I'm happy to answer any questions.
Wonderful presentation, Andy. We do have some questions for you. First of all, we have Les Short is just saying hello, so he wanted to
Hi,
make
Les.
sure that was known.
Yeah.
And our next question is, all appliances and light energy inputs will eventually turn into heat. This heat needs to be accounted for when doing an energy evaluation of the home. Is this done?
Yeah, I believe in Passive House and Net Zero, that kind of calculation is being done. And Gary, feel free to jump in. I know that Gary's got more of a base in Net Zero calculations and planning. But yes, if there is effects happening from the occupants, from use of appliances, from lighting, that will be factored in to the overall calculations that will happen to determine what kind of heating loads and energy demand are going to be required or happening in the building.
Yeah, that's very much true, Andy. And you know, in the past, you know, the amount of heat that was provided through lighting and appliances was higher. And now, as we're moving towards LED type lighting, there's not as much heat generated through the lighting. And also, appliance manufacturers are making many of the appliances consume less energy, and therefore there's less heat generated there. But those things are taken into account for both the heating load and for the cooling load.
Great. Next, we have a question from Cindy. Energy advisors are an important partner for homeowners and contractors in going down efficient deep energy retrofits. What are your thoughts on leveraging the integrated design process, IDP, for efficient and effective deep energy retrofits? She also says it is important to consider the house as a system and look at the total cost versus unit cost.
Definitely, 100% agree. And integrated design process, it's been around for a little while now, and I think it's been used quite effectively for large developers, commercial, you know, in the ICI sector, where projects in the many tens of millions of dollars would have been working. But you start to see that integrated design process within service organizations where energy advisors will be dealing with neighborhoods or dealing with individual homeowners. The integrated design process is definitely a smart thing to do, just because then you can get tradespeople, you can get the energy advisor, you could get the energy modeler, you can get the stakeholders involved in the project to provide their best information to how to make the process, that project move forward in the best possible way to achieve the results that they're looking for. It's going to be a challenge to, though I think it would be a fun thing to get into, it's going to be a challenge to deal with individual homeowners and having that process work for individual homeowners. But given the scale, and if it's the Cindy I'm thinking of, given the scale of the work that needs to be done, it's going to have to come to large government initiatives, which will then link into processes like integrated design. And we have the capacity to identify archetypes of homes, building eras, you know, before the 1940s or from the 1940s up through the 1970s. We can do that, and some of those elements are going to be the same when you look at those certain eras. The insulation details or mechanical details, they will be relatively the same, and so the design process might be able to be taken from one and planted over to another and still work.
Great. That was the Cindy you were thinking of.
Hi, Cindy.
Next question is, what is the expected cost of a deep energy retrofit for the average Canadian detached home? The average size is 1948 square feet.
Yeah, and that's going to be a challenge, especially now that we're dealing with higher than normal prices for a lot of things. And also, as a builder, I know that there's supply chain for it's lessening now, but it's, you know, garage doors, for example. It used to be you'd have to wait quite a while to get your hands on a garage door. I think that's improving now, but if we were to compare a retrofit in Vancouver versus a retrofit in Flin Flon, or in Halifax. You might be looking at differing per square foot prices. It's not going to be a set price, just because the newer homes, certainly ones built after 1980, are going to be more efficient than the ones that were built before 1980. You could be looking into $150,000 to do an entire deep energy retrofit, which might be a gut job. It might be taking it back to framing and building it back out again. Some may not require so much. It might be attic insulation. It might be improving the windows. It might be time to upgrade mechanicals, and they'll take advantage of that.
Great. What standards exist to address embodied carbon and the full life cycle from mining and forestry through manufacture to deconstruction and recycling?
I'm going to let Gary answer this one, just because I know he's got his head wrapped around this most recently.
Yeah, currently on the embodied carbon side, there's a lot of work that is going on right now to put in place some standards with regard to that, from the whole range that you described there, basically, from cradle to grave on these buildings, or even deconstruction and salvaging some of the materials to be used in the next building. To date, there are, to my knowledge, in Canada, we have no specific regulations, but those regulations are in the process of being created as we speak. So they will be coming out soon. There have been some reports done with recommendations for embodied carbon, where they have done benchmark studies of how much embodied carbon are in a variety of buildings, which includes residential and also the Part 9 larger buildings. They've looked at a range, so we know how much carbon is in the most carbon dense, I guess, buildings, and what's in the lower use carbon buildings. And the recommendations have come out saying to put a cap on carbon, and that cap, and these are recommendations, that the cap would be tied to the tiered energy performance that is in the building code. So as the tiers move forward towards 2030, and the energy efficiency of the building is improved, that also the embodied carbon would need to be improved as well as we move forward. So no official legislation or requirements yet, although there is some on the horizon.
Great. What qualifies an electrician to do the roof installation of the solar panels? They don't have any construction training, right?
There are a few trades that are regulated, like electricians. They have to go through a staged apprenticeship. They have to complete levels of training, and then within their provinces and their jurisdiction, they have to then be a registered electrician. Plumbers, electricians, HVAC technicians, a lot of trades require a certification before you can actually do the work. I know that from experience in working in residential construction, and electricians being around on installs like those kind of things, whether they're installing lighting arrays in a living room, dining room, kitchen kind of open concept, or whether they're going to be setting up for DC converters and some kind of a unit that's in the utility room that's going to help to convert from PVE or do something with wind power, something like that. They're going to be one, working off of plans that come from the architect, and if the plan includes to have solar racks put on a roof, then that's going to be part of the plan. In a retrofit situation, that's obviously going to have some kind of inspection beforehand to make sure that the structure can actually take the weight of that racking. For the most part, our buildings are built well enough where they can take that kind of load. Some are going to require a bit of beefing up. They're going to require some kind of either sistering of new pieces within a roof structure system, or they're going to require that perhaps the solar panels are moved off of the roof and out to an open spot beside the building. In any case, I know from experience that electricians are not going to touch anything that they don't feel is going to be safe. They're not going to be installing systems on a building that are not going to remain safe or get hooked up to the grid safely. And if it were ever a question of whether the roof structure could handle the racking system for solar panels, then they're going to turn back to the general contractor or to the design, the architect, and say, look, this is a problem. We need to look at this. And if that issue gets raised, and then they deal with it.
Great. What are your thoughts around being able to inspect what we expect in terms of workmanship for deep energy retrofits and the individual major retrofit components? Who would be best to conduct site assessments?
Certainly, in a professional capacity, and again, this is one of those trades that is certified, as building inspectors have to go through training in order to become certified building inspectors. A general contractor or a contractor with many years of experience might have the credentials to go and inspect buildings and look for those kind of problems. If you're looking at like the engineering of a building or of a process, equally with energy advisors as well, they have to go through a training process so that when they are diagnosing what's wrong with the building or doing energy audits or doing energy modeling, that they are doing so according to what Enercan has mapped out for them in the EnerGuide rules. When someone is inspecting or certifying that a component, an assembly, a process is functioning to the way it was designed, they're going to have some kind of certification. If it's a building inspector who's going through to make sure the insulation was installed correctly, they're going to be working off of their standard checklist that they have through their building code training. If it's an energy advisor who's going through to do diagnosis on what is the behavior of systems in the building, if HVAC and air leakage and that kind of thing, they're going to be going through with a checklist that's created by their service organization based on Enercan guidelines. And if it's an issue where I've got sagging floors in my 150-year-old farmhouse, I don't know if these renovations will be able to take the load because I think there's structural issues. You'd have to call in professional, the general contractor or an engineer to actually look at this and diagnose and say, yep, based on my experience and certification, this is what you've got and this is where we need to go to solve those problems.
Okay, great. And we have one last question. The refrigerants used in heat pumps today have a high GWP and will be phased out by 2030. Why are heat pumps with these refrigerants being installed if they are so bad for the environment and we will not be able to service them?
That's a great question. I know that there's, in a general sense, we have a lot of work to do in terms of figuring out how are we going to shift away from materials that we have commonly used and that are still commonly used and that may have something called global warming potential. It's not going to be easy. It's not going to be tomorrow. It's going to be over the coming decades. We do need to phase out chemicals, materials, processes that are bad for us, for the environment. And we're kind of getting this cold shock of wake up over the last decade or so to say we got to get on this yesterday. How are we going to actually do that? Well, electrically, like cold climate electric air source heat pumps are better than systems that we've had in the past. They operate more efficiently. They use less energy to do the same job. And if we can do, like as we were talking about, create a very tight envelope that functions well as it just sits there, then we can use less of those systems to do the same job, if you get what I'm saying. As for refrigerants and things like that, I do know that all of these companies, these big companies around the world that manufacture and sell these products, they all have R&D departments who are working tirelessly to try and figure out, okay, what are we going to do? Because they can read the writing on the wall as much as we can. That governments are looking at this, and that maybe not right away, but down the road, there's going to be regulations that they're going to have to adhere to. They're not sitting on their hands. They are doing stuff now. And I'm thinking of our own industry, the insulation industry, the concrete industry, the steel industry, the HVAC industry. Everyone is looking at the issues and figuring out what are we doing in 3 years, in 5 years, in 10 years. How are we going to tackle this problem? So it's not an easy solution that we can just snap our fingers and it's gone. It's going to be a lot of work, and it's going to take a little while.
That's great. And that concludes our presentation for today. Any last words from anyone?
Yeah, I just have one quick comment, I guess. So maybe we can find a way to send everybody the link, but NAMA Canada has a complete database of incentives and rebates all across Canada. It's you can sort by province and then where relevant by municipality or community. It is the largest database of energy efficiency incentives across Canada, and it is yours to use completely for free. You don't need to sign up. There's no bar for entry, so please use as needed. Feel free to share it. It is completely yours. So just check for the incentives and rebates on there. If you just Google NAMA Canada incentives, you'll find it. And then you can search by residential, ICI, and then by province, and you'll find all the information there. But please do use this to your advantage. It is totally free and it is totally yours.
That's wonderful, Jillian. What a great incentive. I also just wanted to let everyone know that NAMA Canada will be doing another webinar in about a month's time, so please check back to our website frequently. This recording will be made available to you in your inbox within 24 hours after it is rendered. Thank you, everyone, and have a wonderful day.